Hey, I really like this section because of the three methods, we have the substitution method, which is get the x or the y by itself and plug it into the other equation. We have the graphing method, graph one line, graph the second line, see where they cross. And today we have the elimination method. I believe if you can do two things really well, you're going to love the elimination method. Okay, so let's talk about those two things. First of those two things is know what opposite numbers are. Do we know what opposite numbers are? Like what's the opposite of 8? Negative 8. What's the opposite of negative 17? Positive 17. So if you know what opposite numbers are, which I think most of us picked up what that was, we're good. The second thing is add. If you can add, you're also going to be able to do this pretty well. Okay. Okay, so this is the last of our three solving methods, and it's going to be the elimination method. So that's going to be a learning target. So I'll point out exactly what kind of problems you'll have on the learning targets for today. Okay. You could read through these like kind of core concept. It's going to give you a little bit of a walkthrough of what I'm going to do anyway. But, I kind of like my own way of doing things. So I'm just going to jump right into the example down below. Okay. Your first thing that you're going to try to identify, okay, is what you want to identify is, do you have opposite variables? Do you have variables that is well, let's just go through it, 3x, what's the opposite of 3x? Negative 3x. Does the other equation have negative 3x? So are they opposites? No, they are not. What about 2y? What's the opposite of positive 2y? Negative 2y. Is this negative 2y? Yes. Yeah. So what you can do is you can actually just add the two equations together. Okay, and I'm going to explain why you can just add the two equations together. But if you don't like y, then you just have to know that you can add the two equations together. The right side says that this is 4. So this left side, because of an equal sign, so that means this left side is also 4. I know it's a little blurry. So this is 4 and it's equal to 4. So this right here actually is just 4. And we know properties of equality allow me to add the same amount to each side. So this is how you're going to add it. What's 3x plus 3x? Okay. What's 2y plus negative 2y? 0. So it just cancels out. And that is the magic of the elimination method. When you add opposites, they add to what number? 0. Okay, what about 4 plus negative 4? Happens to be 0 also. This one I'm not going to cross out and I'm going to write 0 because I need something written on that right side. Okay, how do I solve for x? Divide by 6. I'm going to divide by 6 on both sides. X is equal to 0 divided by 6 is 0. Okay. Any questions about that? What do I still need to find now? I still need to find y. And how can I find y? I can plug the 0 in for the x's. Should I do the top equation, the bottom one? Does it matter? No, it does not matter. It doesn't matter if I choose the top or the bottom. Suppose I'll choose the top. 3 times 0 plus 2y equals 4. 3 times 0 is 0, so I'm not even going to write that. So now I'm just left with 2y equals 4. And how do I solve for y? Divide by 2. So y is equal to 2. So if I were to cross if I were to graph both of these lines, they would cross at the ordered pair. X is 0, y is 2. So that is on the y-axis above the origin 2. Okay, that's the general concept. I wish all the problems were as easy as what I just showed you. They're not going to be. Okay. But do I have any questions about what I've done right now? All right, let's move on. Okay. So now what we're going to do is we're going to do an example of like, what do we do if there aren't opposites? So let's walk through the same thought process. What's opposite of negative 10x? Is that positive 10x? No. What's opposite of 3y? Is that negative 3y? All right, so now most of you are hoping I just say, well, we're done. We can't do it, but we can. So let's go back to the x's. You said the opposite of 10x is what? Or I guess I misspoke. Yeah, well, the opposite of negative 10x is positive 10x. And this is a negative 5. Is there something I can multiply negative 5 by to become positive 10? Negative 2, right? Because positive 2 would get me to another negative 10. I don't want two of the same. I want one positive and one negative. So I can actually do this. I know that the properties of equality allow me to multiply an entire equation by a number, as long as I do it to the left side and the right side equally. Okay, so I'm going to multiply the whole bottom equation by negative 2, because we realize that the opposite of negative 10 is positive 10, and I can multiply negative 5 by negative 2 to become negative 10, or positive 10. So negative 2 times negative 5 is a positive 10x. Negative 6 times negative 2. Yep, positive 12y, so I'm going to put plus 12y. And then 23 times negative 2 is, okay. So now what I want to do is, before I look ahead, do I have opposites in the x's now? In the x's? I do. So what I'm going to do is I'm just going to copy that top one below so I can do my work. All right. Any questions about that part that I did in red? Could I have created opposites in the y's? Yes, I could have. Right? I could have multiplied the top one by positive 2, because then I would have ended up with a negative 6y, and then 3 times 2 is 6. So I would have ended up with opposites in the y's. You can pick whatever variable you want. It doesn't matter. I just realized 10 first. Okay, what do I do once I have opposites? Add. You're going to add the two equations. So you're always going to see me put a little plus sign. There's ways that you can do this to minus. I always just teach it one way and one way only, opposites and add. Okay, negative 10 or positive 10x plus negative 10x cancels out. 12y plus 3y. Negative 46 plus 1. Negative 45. And now I just need to solve for y. Okay. Negative 3. Okay. Questions about that? Now I need to actually solve for x. So I should plug this into one of the equations or the other. It doesn't matter which one. You get a pick. I suppose the top one to me looks like it has less negatives. There's a bunch of negatives here. I suppose I'll do the top one. Doesn't particularly matter. So I'm going to replace y with negative 3. Three times negative 3. So positive times a negative is a 3 times 3 is 9. And now to solve, I do what? Plus 9. Nine plus 1 is 10. And then divide by negative 10. You know. So these two things cross at negative 1, negative 3. Okay, so as I look at the monitoring progress problems 1, 2, and 3, okay, I am going to look as I look at number 1. So, sure. Okay, so as I look at problem number 1, monitoring progress 1, would I have to multiply there? Would I have to do any multiplication there?
No,
Why not?
because 3x and negative 3x.
I already have opposites, positive 3x and negative 3x. I could just add right away. Okay, what about number 2? Would I have to do any multiplying there? Yes, I would. 3 and negative 3 are opposites, but are negative 3y and positive 3x opposites? No, they're not, because the variables are different. So I would have to do some multiplication here. What about 3? Yes, I would. I have no opposites. Okay, which one of these 3 do we want to do together? We're going to do one of them. Which one maybe looks like the hardest, or 2? Okay, let's do monitoring progress 2. Okay, so as I look at this and I look at the previous 2 examples, I created opposites in the x's both times. So I'm going to create opposites in the y's here just to show you that you can use either of them. Okay, so when I look at this, you have to try to know what variable or what equation to multiply. If I look at this, this already has a value of 3, right? So this is the one that has a value of 1. So this is the equation I want to multiply. Okay, so if I have 1 here and I have negative 3 here, what should I multiply the bottom equation by to create opposites in the y variable? 3. Okay, 3 times 3x, 9x. 3 times 1y is 3y. 3 times 12 is 36. Okay, then I'm going to just take this top equation and copy it below. All right, do I have opposites in the y's?
Yes.
I do. So what do I do once I have opposites? I add them. 9x plus 1x. 3y plus negative 3y. Cancels, they're opposites. And then 36 plus 24. So 36 plus 4 is 40. And then 40 plus 20 is 60. Some of you all are just smarter than I am. Know your math facts better, I guess. All right, and then what do I do now? Divide by 10. It's a 6. All right, so now I suppose I'm just at the point where I plug it in. Doesn't matter what equation I plug it into. I can pick whatever one I want. Anybody have a preference? Okay, that's fine. Saying that he would just, this is just an X, so he just do that because it feels like it's easier, which is okay. 6 minus 3y equals 24. That's a positive 6, so I would have to minus it from each side. It's 18. And then I would divide by negative 3. So y is negative 6. So x is positive 6, y is negative 6. Okay. Besides the practice problems, that's it from the packet. We're just going to move on to that paper that I handed you guys just a second ago. Okay. And we're not going to be on the word problem side. We're going to be on the regular problem side. So we're going to do this one. So we're going to have 2 more for you, and then the word problem, and then that'll wrap up today. Okay. So as I look at this problem, the first thing I want to try to identify is, do I have opposites anywhere in x's or y's? No. The next thing I want to look at is, what's the opposite of positive 15? Is there any nice, neat whole number I can multiply 4 by to become negative 15? Not really. Okay, what's the opposite of positive 5? Is there any nice, neat whole number I can multiply 2 by to become negative 5? No. So this is what I'm going to do. Ready? Instead of trying to get 1 to positive 5 and 1 to negative 5, I'm going to get both of them to 10. I'm going to get 1 to 10 and 1 to negative 10. Okay, where did that 10 come from? How did I did not pull this out of the sky. Where did it come from? I just went 5 times 2, which is 10, and I'm going to get 1 to 10 and 1 to negative 10. Okay, now it doesn't matter which one gets the positive 10 and which one gets the negative 10. You get to pick. All right, so which one would we like to be the negative 10 equation? Top or bottom? Top, okay. We'll do the top one will be the negative equation. And then if we're choosing the top one to be the negative equation, the bottom one has to be the positive equation. Okay. If I chose the top to be the positive equation, the bottom would have to be the negative equation. Okay, so I want to get this top one here. I want to get this 5 to become negative 10. What do I have to multiply positive 5 by to become negative 10? Negative 2. So I have to multiply this whole thing by negative 2. All right, and the bottom one, we decided, hey, that one has to be positive 10. What do I have to multiply the positive 2 by to become positive 10? 5. Okay, so this is about as difficult as it gets, okay? Because everything after this part is the exact same. You'll have opposites you add and solve. Okay, so does anybody have any questions about what I have here in red and blue? Does anybody know what I would try to get to if I tried to do opposites in the x's? What number would I try to get to? 60, 4 times 15. But we did the y's. Okay, ready? Negative 2 times 15, negative 30. Negative 2 times positive 5 is negative 10. That's perfect. That's exactly what we wanted to see in the first place. And then also 5 times negative 2 is also negative 10. Okay. 5 times 4, 20. 5 times 2. And 5 times 2 again is also 10. Okay. So as you can see, you can scale both of the equations up. It doesn't change their value as long as you multiply both sides by whatever number you're multiplying by. Okay, do I have opposites now? Yes, I do. And when you have opposites, you're going to add. Negative 30 plus 20 is a negative 10. Okay, negative 10 plus positive 10s are opposites, so they cancel out. Negative 10 plus positive 10 again. Negative 10 plus positive 10 is 0, but since there's nothing else there, I don't want to cancel everything out. I'm going to want to write 0. Okay, and then I can solve. Negative 10 times x equals 0. Divide by negative 10. X is equal to 0. And then, like I said, this turns into the same type of problem we've had over and over and over again. Okay, well, it's just the starting point might be a little different. We're going to take that X value, we're going to plug it in. I'm going to use the bottom one, just the numbers are smaller. 4 times 0 plus 2y equals 2. Okay, 4 times 0 is 0. So this will just go away. So I'm just going to kind of cross it off. So then I'm just left with 2y equals 2. And divide by 2. Y is equal to 1. So my answer is 0, 1. Okay. You want to keep this paper. You maybe want to put a star by it. This is definitely a learning target quality problem. Okay. You're going to have one where you have to multiply both equations. And you're going to have one where you need to multiply by one equation. Okay. All right. So since this is a little bit of a harder one, I do have one more right below that will do. And then we'll move on to the word problem. Okay, so we're going to go through the same thought process, even though I already know that we need to multiply both equations. Okay, so 5 is a bigger value. What's the opposite of positive 5? Is there anything I can multiply negative 4 by? Nice, neat whole number, so it becomes negative 5? Not really. Opposite of 25 is negative 25. There's not any nice, neat number I can multiply 3 by to become negative 25. So this is an example where I'm going to want to multiply both equations. Okay, and you're going to pick what variable. What variable do you think is the easiest? X is going to be the easiest for us because of 2 reasons. 1, 5 times 4 is 20. That's pretty easy. I'd say multiplying to 20, most of us have a pretty good grasp of that. The other reason is we already have one positive and one negative. So naturally to me, which equation is going to want to be the negative one if the 4x is already negative? Do we want the top one to be the negative equation or the bottom one? The bottom one's just naturally already set up to be our negative equation. Okay. Now you could choose the top one to be the negative one and the bottom one to be the positive one. And if you do everything right, you're going to get the correct answer still. I just think that this is less work. Okay, what do I have to multiply the top equation by to become positive 20x? And what do I have to multiply the bottom equation by to become negative 20x? Just 5. So notice since 1 was already negative, both of these numbers ended up being positive. All right, 4 times 5 is 20. 4 times 25 is 100. 4 times 85. I probably could try to do that in my head, but off on this side, I'm typing that in a calculator. I can't think of one situation where you're not really going to have a calculator for like graded work we do in my class. So if you don't know, just use a calculator. 5 times negative 4 is negative 20. Somebody mind shutting the door? So my guess is going to be like a stampede. Thank you. 5 times 3. 5 times 24. 120. Do I have opposites? And what do you do once you have opposites? Add. We're going to cancel them out with addition. These cancel. This is 115. And this is 460. Just the first solving steps just go by so much faster for me. I feel like that's why I like this method. All right. And then I divide by 115. So y is 4. You get to pick what problem to substitute 4 into. I could see arguments for either of them. I am going to use the bottom one just because the numbers are just generally a little bit smaller. But you can do whatever one you wanted. Okay, 3 times 4 is 12. I can subtract 12 from each side here. End up being 12 again. And then divide by -4. Answer -3, comma, +4. All right. Again, that's another really good learning target example. Make sure you hang on to this paper. I understand it's not part of your note packet, but these are 2 types of problems you're going to have. Okay. We're going to do the backside. Backside has the word problem. So the word problem out of the book, we're not going to do because the way you write those equations we should know how to do those already because we covered how to do that in chapter 4, but that was a long time ago. So plus this is going to be more representative of the learning target question that will be on your test and on your learning target for the day. And plus, this is a fantastic problem. Yeah. Plus, this is a great problem as I can see you doing something like this in science. Or if you're like you only need like a certain percentage of bleach. Like sometimes you have to like mix bleach with water for certain reasons and you have to dilute them to a certain amount. So this is just overall a pretty good problem, I think. Okay, so you're making 8 quarts of fruit juice for a party. You have bottles of 75% fruit juice and 50% fruit juice. How many quarts of each type should you mix so that you have 8 total quarts of 60% fruit juice, okay? So there's 2 things going on. There's a total amount of liquid. How much total amount of liquid is there? 8 quarts, okay? The other thing is that there is like a percentage of juice, okay? So when I have 75% fruit juice, if I have 8 quarts of 75% fruit juice, that means there's only 6 quarts that are actually fruit juice. And the other 25 is, I'm assuming, water, but I don't know for sure. Okay, so there's 2 things that we need to work on, okay? We need to work on making sure we understand what decimal represents what percentage. So if I have 100%, does anybody know what decimal represents that? 1, just like the whole number 1, okay? But if I have 75%, what decimal is that? Yeah, 0.75. Okay, 50%? Okay. And then I'm going to do 5% also. Anybody know what 5% is as a decimal? Okay, yeah. Just make sure if it's a single digit like that, and I don't know if there is, that, a lot of people for 5% will put 0.5, and that's 50%. Okay. All right, there's 2 equations. We should probably, we had the problems with like multiple choice and essay problems, right? M and E would be great variables for that. I don't really see very good variables for this one. So I'm just going to choose X and Y. And in this one, I really, really want to label what my variables are. I mean, you want to do that in every problem, but more particularly in this one because I don't have like E for essay and M for multiple choice. I don't have something that's very obvious for me. Okay. All right. First equation is going to represent my total quarts. How do I represent my total quarts? There's 8 total quarts. And my 8 total quarts is made up of what? 75 and 50% fruit juice. All my 75 quarts plus all my 50% quarts is equal to 8 total quarts. Okay. My next equation is my percentage of fruit juice. Percentage of fruit juice. What's the total percentage I want of fruit juice? 60%, right? So we have to be a little bit careful. It's 60% of how much juice altogether, though. How much juice am I going to have, or how many quarts am I going to have altogether? 8, and what percentage of that needs to be fruit juice? So I have to be a little careful here. I have to go 60% of the 8 quarts is what it's all equal to. I think this is one of the tougher problems we have set up for, okay? Again, there's 8 total quarts and 60% of that needs to be fruit juice. So I need to multiply 60% times 8. Okay? What's the next thing I need? What? My percent juice of 75% ones, right? If I take all my liquid here, however many quarts that is, 75% of that is fruit juice. So if I have 2 quarts, 1.5 of those quarts is fruit juice. How would I represent the next one? 0.5 what? All right. Again, setting up the problem correctly in our class is heavily weighted. This is 3 out of 4 points if you do nothing else. Okay, do I have any questions? Okay, there is, when you do the word problems, there is not one way you have to solve them. Okay, you can solve them in whatever method you want. Okay, so you get to pick. Since we're on the elimination method lesson, I'm going to choose to do the elimination method. Okay, but if you really like substitution, this problem's not poorly set up for substitution. Okay, the first thing I want to do is actually figure out what this number is. So I'm going to take 0.6 times 8 in my calculator off on the side. And when I do that, I'm getting, this is actually just 4.8. Okay. And what I can do, because when I have X, that's how many X's? Everybody should know this one. Come on. When I have just X, how many X's is that? 1. 1 is easily manipulated, right? You can multiply that to basically anything you want. So I'm going to look at the X's. That's positive 0.75. What's the opposite of positive 0.75? What do I have to multiply 1 by to become negative 0.75? Negative 0.75. So I'm going to, because 1 is so easily manipulated, I'm just going to multiply the top one by negative 0.75. Okay, so here this ends up being negative 6. You could take your calculator, negative 0.75 times 8. And then I'm just going to copy the equation written in black right below. Do I have opposites? What do I do when I have opposites? Add. -6 plus 4.8 is negative 1.2. Negative 0.75 and positive 0.75 are opposites, so they cancel out. And then this here is negative 0.25. Just add if you don't know. Negative in your calculator. Okay, then I can divide by negative 0.25. Ooh, 1/4. Oh, this is times by 4. So this might be 4.8. Okay, take my calculator. It did end up being 4.8. So you get 4.8. What does 4.8 is equal to y mean? Okay, so I need 4.8 quarts of 50% fruit juice. So then I take that and I plug it back into the other equation. And x equals 3.2 means 3.2 quarts of 75% fruit juice. Okay. Again, this is another great learning target problem. It's the same thing. The numbers are just moved around. Okay. Same for your test. We're still a little ways from a test yet, but your test is going to have whatever was on the learning target for word problems. Those exact same type of word problems are going to be on your test also. Okay. Here are your practice problems for the day. Number 3 through 18, 21, and 33. Okay, number 33 for sure needs to be done by you. It's a word problem just like what we did. Use this as a guide. Okay, and then you have to do a minimum of one other type of problem. Okay, if I'm you, I'm doing a problem where I have to multiply both equations. So I think if I looked at this correctly earlier, I think 17 or 18 would be really high quality type ones for you. Yeah, 17 or 18 would probably be the best type of ones for you, okay? Otherwise, at this point, it is just work time, okay? And let me know if you have questions.